You've seen how the aeroplane has been developed into a weapon of war, being used to track and spot the enemy, monitoring their every move. You've seen how the mighty bombers can, in a single blow, devastate a complete city. This next breed of aeroplane not only needed superb handling characteristics and electronic devices, it also needed the tenacity and courage of the young pilot behind those controls, the fighter pilot.
The earliest forms of fighters were known as fighting scouts because they often had to fly scouting missions in between dogfighting with the enemy. Another duty was bomber or reconnaissance aircraft escort. The interceptor or pursuit aircraft was at first a fast climbing fighter to protect home targets. Today this term describes all fighters used in a defensive role.
They get rid of their long-range wing tanks before the fight. And down they go for the kill. With a touch of a finger on the stick, a camera and 8 machine guns are put into action. Small cameras set on the wings make the record. Too often poor pictures due to gun vibration. But they let you see what happens at the instant of action, as the pilot.
Modern-day interceptors carry radar and are both daytime dogfighters and night fighters rolled into one. Almost all of them carry many tons of bombs or missiles and are frequently used to strike at surface targets. A few far-sighted people thought through the possibility of air warfare many years before World War I and came up with proposals for fighter aircraft that could be used to shoot down opposing enemy aircraft. Several inventors proposed synchronized gear, which, linked with a machine gun and the aircraft's engine, would allow the bullets to pass safely between the rotating blades of the propeller. Others proposed pusher aircraft, in which the problems of mounting a machine gun disappeared. The early Wright flyers were pushers, as was the British FE-2. They had their guns mounted in a nose section forward of the propeller. When World War I broke out, there was no such thing as a fighter pilot, or any accepted techniques for air combat. Two-seaters soon began to carry weapons such as rifles, pistols and carbines, which could be fired by the observer. But as the war progressed, the ideal appeared to be a small single-seat plane where the pilot could fire a machine gun straight ahead. Captain de Havilland designed the DH-2 as a true single-seat fighter, with left and right mountings for a Lewis machine gun. But this aircraft had little success. The pilot had to work the rudder pedals, control column, throttle, aim the gun, work the trigger, and change magazines whilst looking through the gun sights. Many different theories were tried and tested, and in fact some early aces like Lano G. Hawker of the Royal Flying Corps kept on shooting down enemy aircraft with nothing more than a single-shot Martini rifle. Before 1914 was out, several pushers had appeared with guns fixed to fire straight ahead. This left the pilot free to operate the controls and aiming the gun by aiming the whole aircraft. A French inventor came up with another solution. He designed steel channel-shaped deflectors on the propeller blades, which would allow the rounds to pass through. His test pilot, Roland Garros, achieved much success with the system, but unfortunately he was shot down and captured by the Germans. One of the greatest ideas of military importance had been allowed to fall into enemy hands. The Germans quickly reassembled Garros's deflectors and passed them over to the German manufacturer Anthony Fokker. He did better than copy the system. He redesigned it. Fokker came up with a system which would, by the use of an interrupter gear, fire a machine gun only in the split second when there was no propeller blade in front of it. The gun was fitted to the Fokker E-types, and this triplane machine, at the hands of the young and dedicated fighter pilots of the German Imperial Air Force, became lethal weapons. The German pilots had spent a great deal of time and thought in how best to approach air fighting, and they terrorized the skies. The infamous Red Baron, Manfred von Richthofen, was one such pilot. The Red Baron scored 80 victories over Allied fighters. So heavy were the Allied casualties that newspapers wrote of the Fokker scourge, calling Allied pilots Fokker fodder. But their dominance of the skies was short-lived. The British quickly developed their own fighters with the same technology. The Sopwith Pup, the Bristol Scout, and the Nieuports very soon were fighting back with a vengeance. The most successful fighter of the war was the British Sopwith Camel, which was attributed to shooting down more than 3,000 enemy aircraft. A score that was far in excess of any of its contemporaries. World War I was the first war that was fought in the air, and not only was there now a new type of weapon with which to wage that war, but also a new type of warrior, the fighter pilot. To the regular soldiers, these new men were a strange breed. They wore unusual uniforms. They spoke of peculiar forms of warfare. They were young, high-spirited individuals with little care for military traditions or customs. But their worth soon became more than apparent. The Fokker DV-11 was perhaps the most outstanding aircraft, although this was never used until late 1918. As the 1920s approached, two new factors emerged. The first was the introduction of naval fighters, and the second was the emergence of new air forces. The United States had been unprepared for war in 1917 and had relied mainly on British and French aircraft. But in the 1920s, its own industries flexed their muscles and produced increasingly complex fighters. Almost all of them had air-cooled radial engines and were built with all-metal structures. They were fitted with the powerful Browning machine guns. As 1935 approached, many fighter pilots continued to insist that a fighter had to be a biplane with an open cockpit in order to offer the best all-round view and the greatest possible maneuverability. The British Air Ministry, however, had different plans. They concluded that in any future war, the time available for shooting down an enemy bomber might be as little as 2 seconds of accurate shooting. They calculated that to achieve this, they'd need a gun capable of firing 250 rounds in those 2 seconds, about 8,000 rounds a minute. The answer seemed to be in using 8 machine guns. They chose the American Browning. New fighters with 8 Brownings were going to need at least 1,000 horsepower. For that, they chose the Rolls-Royce Merlin engine. Around this superb engine, the Hawker Aircraft Company produced the Hurricane. Although fabric-skinned, this aircraft was tough and highly maneuverable. Shortly afterwards, to the same specification, the Supermarine Company produced the immortal Spitfire. In Germany, the Messerschmitt Company came up with the Bf 109, smaller than the Spitfire, but equally as deadly. The 109s shot down more aircraft than any other fighter, not just in World War II, but in aviation history. Many nations also thought at the outset of World War II that there'd be a need for bigger fighters, not to be used for dogfighting with other fighters, but to shoot down the bombers. From Britain came the Blenheim, the converted medium bomber, an aircraft that was deficient in speed, maneuverability and firepower, and nowhere near as efficient as the German purpose-built machines. Blenheim losses were heavy. The Luftwaffe's Bf 110 was the pride and elite of the nation. But by 1940, it was found to be no match for the tenacious young Spitfire and Hurricane pilots. It was also at this time of the war that the RAF found to their surprise that a fighter with a power-driven gun turret was becoming easy meat for the enemy fighters. The only saving grace of the Blenheim, in fact, was that it carried early airborne radar equipment. It was followed by a vastly superior machine, the Bristol Beaufighter. This aircraft became the most widely used Allied night fighter. Another outstanding aircraft was the de Havilland Mosquito. First conceived as an unarmed bomber, it was very soon modified into the greatest night and long-range fighter of the war. Much faster than the Beaufighter, it had 4 20mm cannons, and initially 4 machine guns as well. It also carried bombs or rockets, and had enough range to hit targets in the Balkans or Scandinavia. In 1940, the fighting in Europe caused the Americans to re-look at their fighter designs. they felt that it was necessary to double the horsepower of their new types. The Vought company built the 2,000 horsepower Corsair with the largest four-blade propeller ever fitted to a fighter. The Republic company built the P-47 Thunderbolt. And Grumman followed with the F-6F Hellcat. With such enormous power, these fighters could outfly their opponents, despite having heavy fuel loads, heavy armament, and considerable armor-plated protection. There were 12,000 Hellcats produced, 12,000 Corsairs, and over 15,000 Thunderbolts. At first, their enemies were much smaller and lighter. The Japanese Zero, by comparison, was only 1,000 horsepower. A special quality of this aircraft was its very long range, which enabled it to conquer vast areas of the Pacific and Southeast Asia when operating from distant airstrips. The Zero was fast, heavily armed, and was highly maneuverable. But far from being invincible, the aircraft was actually deficient in flight performance compared to its adversaries. It also had very poor defenses and was very easy to shoot down. In Europe, the Luftwaffe produced even greater quantities of 109s, despite the fact that it also introduced a vastly superior machine of completely new design. The Focke-Wulf 190. This was one of the most outstanding fighters of the war, with unsurpassed technology and engineering design. Replacing the Ju-87 Stuka, it became the chief tactical attack aircraft of the Luftwaffe. The Second World War proved that the aircraft had developed into one of the most important weapons of war, if not the most important. By 1944, jet propulsion was fast opening up new horizons in aircraft performance, and especially to fighters. First to reach the squadrons was the radical German Me-163 Comet, which was a tailless rocket interceptor with very short endurance. Though superb to fly, it was designed to take off from a jettisoned trolley and land on a skid. This, coupled with the danger of its highly reactive fuels, made flying it both tricky and dangerous. The much bigger Me-262 was an even more formidable aircraft. Because of its speed, the aircraft was impossible to catch unless taken by surprise on takeoff or landing. The first jet fighter to become operational in Britain wasn't until July 1944, with the arrival of the RAF's new Gloucester Meteor, but very few of these saw any action. After the war, the Meteor was given much more powerful engines, gaining a world speed record in full fighting trim. A far more significant jet fighter was the North American Sabre. North American had been asked in 1940 to build the old Curtiss P-40. Instead, they built a fighter of their own design, the Mustang. Fitted with the Merlin engine, the Mustang became one of the outstanding fighters of the war, combining performance at all heights with enough range to escort bombers from England to Berlin. The Mustang was the natural aircraft to be fitted with a jet engine, and it was this aircraft that formed the test bed for the Sabre. In June 1950, war broke out when North Korea invaded South Korea, and very soon Allied fighters were brought in to help in the conflict. The jets were soon handicapped by their inability to use short, rough airstrips or carry heavy bomb loads, because the early jets burnt fuel very quickly. The Americans brought back the Mustang, along with other earlier propeller-driven aircraft, to use as attack planes. But things quickly changed over the skies. The North Koreans had brought in Russian MiG-15s. Very soon, the Sabre jets were back in action in the first jet dogfights against the MiGs. Of the many jet fighters built in the 10 years after World War II, the most innovative were the interceptors of the US Air Force. These carried totally new radar fire control systems, in which powerful radars, autopilots and computers were linked to steer the aircraft automatically and to shoot down intruders at night or in bad weather. Using these new systems, this could all be done without the pilot ever having to see the enemy. These developments revolutionized fighter design, and by the 1950s, it was clear that all new fighters were going to need radar. On the 27th of May, 1958, a two-seat twin-jet carrier-borne aircraft named the Phantom made its first flight in St. Louis. For the next 20 years, it provided the yardstick for all other jet combat aircraft. What made the Phantom F-4 so special was its outstanding all-round performance. In nearly every respect, it exceeded the capabilities of existing specialist attack or fighter aircraft. The F-4 established a new speed record, an astonishing 1,606 miles per hour, and broke every time to height record in the book. In April 1957, the British government produced an astonishing white paper. It announced that all manned fighters and bombers were obsolete, and that all future attacks would be made by ground-based missiles. This must have come as quite a surprise to the Americans and Russians, who were spending billions on the design and manufacture of new aircraft. The English Electric Lightning, however, had gone too far to cancel. Consequently, it survived to become the first and only truly supersonic fighter of British design and manufacture to see service with the RAF. The Lightning pioneered high thrust-weight ratios and moderate wing loading. The two afterburning Avon turbojets were arranged one above the other in a deep fuselage and were fed by a circular nose inlet. The RAF finally joined the Mach 2 Club when No. 74 Squadron received their first F-1 single-seat all-weather interceptors in 1960. The Lightning immediately established itself as a pilot's aircraft with exemplary handling and climbing performances. The rate of climb was an astonishing 45,000 feet a minute, over 700 feet a second. Britain's second potential Mach 2 fighter, the Fairey Delta II, was cancelled in the missile madness of 1957. But this prototype gave birth to the French Mirage 3. An aircraft that was a major credit to the French aerospace industry of Dassault, and went on through many variants to become one of the leading supersonic fighters in air forces throughout the world. The McDonnell F-15 first flew on the 27th of July 1972. Named the Eagle, this aircraft was designed purely as an air superiority fighter. It combined a formidable medium-range multiple kill capability with the exceptional maneuverability and acceleration needed for visual range dogfighting. Outwardly, it appeared very similar to the MiG-25, but inwardly, the Eagle could not have been more different. The deceptively simple wing was a masterpiece, optimized for maximum high subsonic turning performance, yet coping easily with both Mach 2.5 and low-speed flight. The pilot enjoyed an all-round view thanks to a high seat position and large teardrop canopy. Having been originally designed for 2 crew members, there was adequate room for a conversion to operational trainer units and Strike Eagle versions. Single pilot operation was made feasible with the very first use of hands-on throttle and stick systems. This meant that all of the vital switches for the radar and weapons came literally to hand instead of being scattered around the cockpit. The F-15 has probably shot down more aircraft than any other jet fighter in the last 25 years. The Israelis used them against the Syrian MiG-25s in 1982, and more recently the Eagles of the US Air Force destroyed many of the Iraqi aircraft lost during the Gulf War. Thanks to the sustained development of jet engines, today's fighters no longer suffer from limited endurance and weapon load, such as that shown in Korea in the 1950s. Even the smallest can use short airstrips, carry 5 tons or more of bombs, and fly a 4-hour mission. The Sepicat Jaguar requires no runway at all. Equipment always includes an ejector seat, comprehensive ECM and other defensive decoys, and a flight refueling probe giving almost unlimited endurance in the air. First flown in February 1974, the General Dynamics F-16 Falcon was a landmark in fighter design. Originally conceived as a lightweight fighter to complement the more costly F-15 Eagle, the F-16 has grown from a lightly armed, clear weather fighter into a potent multi-role combat aircraft. It was the very first aircraft to use artificial stability and fly-by-wire, setting new standards for maneuverability, turning 9 Gs almost instantaneously. The cockpit was one of the first to use head-up display, and the pilot uses a force-sensing side stick rather than a position-sensing conventional stick. The latest fighters in development are a completely new breed of aircraft. The Eurofighter 2000 is due to enter service early next century. This aircraft is the ultimate in high-technology systems, electronics, and sophisticated materials. Electronic flight systems, fly-by-light and ultra-fast computers mean that the pilot can take this aircraft to the limit with extreme agility and without any fear of losing control. It'll be the first fighter with a fully operated helmet-mounted sight system for the pilot. He or she can designate the target by simply looking at it, then calls up the appropriate weapon either by direct voice command or by pressing a button on the throttle. In automatic mode, the onboard computers do the rest, firing the missile at optimum range. Using this method of attack, a pilot could actually fire a missile at an aircraft alongside him. The missile, once released, would turn 180 degrees before exploding within lethal range of the target. Engaging targets in this way limits an opponent's options for evasive action and leaves the launch aircraft clear of any debris from the victim.
In World War I, the existence of naval air arms as separate services prompted the development of air wars at sea. Endless stretches of sheltered water, suitable for the takeoff and landing of marine aircraft, were a further factor. To some degree, military requirements over land and naval requirements at sea ran parallel. Aircraft could fly reconnaissance missions, spot the guns, drop bombs, and endeavour to shoot down enemy aircraft.
In Britain, the Royal Naval Air Service constructed a series of flying boats. There were many other types of flying boats produced by Britain, the United States, France, Russia, and Japan. Some carried torpedoes, and most could fly anti-submarine patrols with AS bombs or depth charges. But aircraft still lacked performance, and the absence of any other way of finding submarines, other than by sighting them in shallow water, made kills few and far between. Between the wars, progress of flying boats was modest, other than the basic development of aircraft in general. But in the 1930s, they were revolutionized by newer and more powerful engines. By 1936, the US Navy had taken delivery of a flying boat that was built in greater numbers than any other in history. The consolidated PBY Catalina. This remarkable aircraft could carry a bomb load of 20,000 pounds and fly a 72-hour mission covering a distance of 6,300 miles without refueling. Nearly all of the flying boats of the 20s and 30s had been biplanes, with a few notable exceptions. The RAF's faithful Walrus amphibian, which was the force's prime air-sea rescue aircraft, and also served with a fleet air arm. Probably the nation that suffered most from the German U-boats was Britain, and it was she that led the world in the development of the air-surface vessel radar. But the main objective of these new radars was their ability to detect the small tip of a U-boat periscope. The short Sunderland flying boat was Coastal Command's main submarine hunter. Later on, the consolidated Liberator was added to the force. By 1944, the ASV Mark V radar was in use. This was carried under both wings of the Sunderland or in the nose of converted Wellingtons. This radar was capable of detecting a U-boat at periscope depth, even in the roughest of stormy seas. Since the 1950s, almost all Western maritime aircraft have been land-based. Numerically, the most important being the Lockheed Neptune, which in 1946 set a world record by flying a staggering distance of 11,236 miles non-stop from Australia to Ohio. A contemporary of the Neptune was the British Avro Shackleton, derived from the Lancaster bomber. This is the RAF's Nimrod MR2. Based on the de Havilland Comet airliner, the Nimrod has proved to be an outstanding and unique jet for ocean reconnaissance. The aircraft also packs a pretty powerful punch.
The first man to take off in an aeroplane from the deck of a ship was Eugene Ely. During World War I, not much attention was given to the possibilities of using a vessel at sea as a platform for aircraft strikes, and it was not until 1918 that the first aircraft carrier was commissioned.
There had been various attempts at taking off from ships, including this catapult system. The first years went by, the carriers progressed along with their array of aircraft. This was the deck of the USS Saratoga during the Vietnam War. Mighty carriers operated by the US Navy during the Vietnam conflict carried a powerful array of aircraft, including the Crusader, the Sky Raider, and the Skyhawk. Later in the conflict, the Phantom, the Corsair, and the Intruders were added to the fleet. Although the Vietnam War brought ruin to both halves of the country and cost untold civilian and military casualties, the US Navy and its carriers could be proud of their dedication and heroism. The carriers had not been used in the manner for which they'd been originally designed. Instead of fast hit-and-run tactics, which had proved effective in World War II, they were forced to remain on station, maintaining combat air patrols and sorties until aviation fuel and ordnance stores were exhausted. Only then could they withdraw to replenish before once again returning to the battle zone. Out of the experience came a new awareness of the limitations of existing carriers, and also confirmation that in future there would be a need for much larger nuclear-powered vessels already in development. Today, the US Navy's Nimitz-class nuclear-powered carriers are the largest warships in history, displacing more than 90,000 tons and carrying a complement of 5,000 men. Each carrier operates a total of 90 aircraft, the most impressive being the F-14 Tomcat of Top Gun fame. The Grumman F-14 Tomcat is the US Navy's carrier-based interceptor and is a highly potent weapon of war. Any hostile intruder that attracts the attention of a Tomcat will come up against an aircraft that's packed with deadly Sidewinder, Phoenix and Sparrow anti-aircraft missiles, capable of hitting their target from a distance of 125 miles away. Today, Britain has abandoned conventional carriers in favour of much smaller Invincible-class warships. Equipped with Sea Harriers and ASW and AEW helicopters. The foredeck of the ship has a curved ski jump, so that when a rolling takeoff's made, the aircraft is projected high into an upward trajectory.
Confirm South Sound. Clear to launch the showers.
In just a relatively short space of time since the string and canvas days of the Wright brothers, the fighter has come a long way. It has become one of the most sophisticated and formidable weapons of war.